Accuride Wheel End Solutions is your only single source for industry-leading wheel end solutions. This video is one in a series to show you the correct method for installing and properly maintaining your Accuride and Gunite brand wheel end components to ensure their maximum performance. Our Accuride wheel product line includes steel and aluminum wheels from a single source for a broad range of commercial vehicle applications. Our wheels hold the #1 and #2 market positions in North America for steel wheels and forged aluminum wheels, respectively. We serve the leading original equipment manufacturers, or OEMs, and their related aftermarket channels in most major segments of the commercial vehicle market, including heavy and medium-duty trucks, commercial trailers, light trucks, buses, as well as specialty and military vehicles. Our commitment to deliver high quality and dependable performance is the hallmark of our full line of commercial vehicle wheels. Servicing of multi-piece and single rims and wheels is governed by a federal OSHA standard. This presentation is an educational tool regarding servicing of single-piece wheels that may supplement the training required by the OSHA standard. This presentation is not, however, a substitute for completing training and other requirements of the standard. To get started, you will need to have the following equipment available: pressure gauge, jack stand, wheel chocks, tire valve wrench, dolly or tire lifting bar, wire brush and file, impact wrench, torque wrench, fast-drying metal primer, aluminum wheel protector, clip-on air chuck, remote inline valve and gauge, and safety cage or other OSHA-approved restraining device. Once you're ready to begin, it's important to complete a thorough visual inspection of the wheel while on the vehicle. First, look at the studs and nuts. Are any of them loose, worn, damaged, or missing? Next, look for rust and corrosion. Rust streaks and corrosion can often be found around loose or missing nuts and studs. Check the wheel for cracks. Look for bent, broken, or worn components. If one wheel stud is broken, replace that stud and the 2 adjacent studs. If more than one stud is broken, replace all of the wheel studs in the hub. Not all nuts and studs are interchangeable. Be aware of improper fit. Refer to the Accuride Rim Wheel Safety and Service Manual to make sure you are using the correct nuts and studs for the type of wheel being serviced. Also, check the tire inflation pressure with a pressure gauge. If less than 80% of the standard running inflation, completely deflate the assembly and remove the wheel assembly from the vehicle. Disassemble and inspect the tire and wheel per OSHA standards. Before working on the vehicle, block the wheels so that they remain stationary. With the vehicle wheels blocked, align the jack on the vehicle axle tube. Once the jack is securely in place, slowly raise the vehicle. With the vehicle raised, place the jack stand underneath the axle tube. Lower the axle to load the jack stand. Ensure the tire is off the ground. Deflate the tire completely by removing the valve core. Run a wire through the valve to make sure deflation is complete. On aluminum wheels, place a protector over the bolt circle to avoid marring the aluminum finish. Remove the nuts from the wheel end assembly with the nut at 12 o'clock last. Remove the wheel from the vehicle using the tire dolly or tire lifting bar, being careful not to damage the stud threads. Stud thread damage can impair proper torquing and clamping force. On aluminum wheels, cover the floor working area with a clean rubber mat to avoid scratching the aluminum surface. To loosen the bead from the rim, Drive the flat end of the swan-necked bead tool between tire bead and rim flange. Straighten tool to an upright position and hammer downward on the neck to pry the tire from the rim. Repeat at about 8-inch intervals until the bead is free from the rim. Turn the wheel assembly over and repeat to loosen the bead on the other side. Lay the wheel assembly flat on the floor with the short side of the rim facing up and break the bead seat as shown previously. Lubricate the tire bead seat area, including the flange, using an appropriate lubricant recommended by the manufacturer. Approved lubricants can also be found in TMC RP205. You will need 2 tubeless tire tools. Use one and insert the curved end of the tool in the tire at valve. Step on the tire opposite the valve to direct the first bead into the well. Pull the tool toward the center of rim, lifting the tire over the flange until it touches both rim flanges. Hold the tool in position with foot. Insert and pull the second tool towards center of rim. Progressively work the tools around the rim until the first bead is off the rim. Insert the straight end of tool between the tire bead and the back rim flange, hooking the tool over the top of the second flange. Lean the wheel assembly toward the tool and provide a rocking or bouncing action to pry the rim out of the assembly. For aluminum and EverSteel wheels, use a clean rubber mat in the working area to prevent scratching the surface. The following information is general instructions for demounting a tire by machine. Be sure to consult the manual for the machine you are using to get the proper demounting instructions. Make sure the tire is completely deflated by removing the valve core and running a wire through the valve. If your machine provides a separator tool, use it to break the bead of the tire. If not, put the assembly on the machine and lock it in place. Position the tool so the flat end can be driven between the tire bead and rim flange. Rotate the tire tool to separate the bead from the rim. Separate tire bead on the other side of rim in the same way. Lubricate the tire bead on both sides of the tire. Insert the tool under the bead. Rotate the tire. Pull the tire up and pull the lower bead off the same way. Once the wheel is removed from the vehicle and the tire is removed from the wheel, inspect all metal surfaces including the rim and the mounting faces of the wheel, hub, and drum. Look for any condition that could impair their proper function, such as excessive rust or corrosion buildup, cracks in metal, bent, broken, or worn components, bolt holes that are worn, damaged, elongated, or have burrs, worn or damaged nuts, bent, stripped, or damaged studs, improperly fitted or mismatched components, irregular mounting surfaces. Replace all parts that are not fit for service with new parts. Never hammer, braze, weld, or attempt to repair a damaged or worn part. Mark and destroy damaged parts so they cannot be reused. The TMC's User's Guide to Wheels and Rims is a good source of information to help determine the cause of wheel problems and the appropriate actions to correct them. Before reinstalling a wheel, use a file or a wire brush to remove any burrs, projections, rust, corrosion, paint buildup, or dirt and grease that could impair proper fit on the mounting surfaces of the drum, hub, and wheel. Painting of bare metal surfaces of the wheel will help prevent rust and corrosion. Make sure the surfaces are clean and dry. Brush or spray a fast-drying metal primer onto all bare metal surfaces of the wheel, including the tire side of the rim. Moisture on bare metal will cause rust and/or corrosion, which may lead to the development of premature cracks. The total paint thickness on disc wheels mounting surfaces must not exceed 3.5 mils, or 3 1/2 of an inch per TMC RP 240, which is about the thickness of a typical magazine page. Avoid paint buildup in critical areas such as the wheel mounting surfaces and bolt hole chamfers on stud-piloted wheels. Allow paint adequate time to cure. It must be dry and cured to provide adequate corrosion protection and prevent against loss of clamping force and potentially nut torque loss. Loss of clamping force or nut torque loss may lead to wheel damage or separation of the wheel from the axle. Refinishing the wheel is another option. There are companies that will strip the paint off the wheel and repaint the wheel for extended corrosion protection. When selecting these companies, make sure their process will not change the mechanical properties of the material or remove excessive material from the wheel. They must repaint the wheel with under 3.5 mils of paint thickness on the mounting surfaces. If the companies damage the wheel in any way, wheel issues may occur. For aluminum wheels, exercise care when working with the visually exposed surface of the wheel. Do not sand, wire brush, or use abrasive cleaner on this surface. Instead, use a 100% cotton cloth dipped in a mild soap solution. Paint is not required nor recommended for aluminum wheels. Remove grease, oil, old rubber, dirt, and road film, especially in the tire chamber, to allow the tire to properly seat upon the next installation. A solvent bath may also be used to clean aluminum wheels. It is important to make sure mounting surfaces are clean and flat. The flatness of a hub and drum can be measured by using a straight edge and feeler gauge. Replace as necessary per manufacturer's guidelines if damage or wear is found. For aluminum and EverSteel wheels, use a clean rubber mat in the working area to prevent scratching the surface. Verify that the tire and wheel are properly matched using data from the Tire and Rim Association or tire manufacturer. Inspect the tire and rim for any damage. Insert the valve stem. Tighten the valve to the torque recommended by the valve supplier. For steel wheels, place the wheel on the floor with the rim short side up. For aluminum wheels, it is possible to mount the tire from either side. To minimize damage to the disc, mount the tire on the wheel with the disc facing up. Lubricate the tire side of the rim and the tire beads using a lubricant that conforms with TMC RP 205. Lay tire on the rim. If there is a balance mark or a yellow dot indicating the light spot on the tire, line this mark up with the valve stem. If there is a red dot on the tire indicating the high spot of tire runout, line this up with the dimple in the wheel if it is marked. If not, line it up with the valve stem. Please refer to TMC RP 243 for a comprehensive list of match mounting markings. Push the lower bead over the wheel flange and into the rim well. Using the straight end of the tool with the stop resting on the rim flange, pry the tire over the flange, starting where the tire bead crosses the rim flange. Repeat progressively around the tire, working with small sections until the tire is completely over the rim. Stand the tire to start the upper bead over the rim flange into the well. When necessary, push a section of the bead into the rim well and anchor with self-locking pliers. Pinch pliers onto the rim flange, snub side toward the tire. Using the spoon end of the tire tool, with the stop toward the rim, work progressively around the bead. Repeat taking small sections around the tire until bead slips over the flange onto the rim. If necessary, insert a second tire iron and again lubricate the last 8 inches of the bead before completing the procedure. Do not inflate the tire to more than 40 psi to seat the beads. If the beads have not seated by 40 psi, remove the air and relubricate the beads. Check to be sure tire and rim size match and there is no interference between the tire and rim. Put the tire and rim assembly in the safety cage or other OSHA-approved restraining device. Use an extension hose with an air gauge and clip-on air chuck. Stand clear of the assembly. Inflate to recommended inflation pressure. Both the tire and wheel manufacturer have inflation pressures. Only inflate to the lower pressure of the two manufacturers' specifications. Tire manufacturers may be able to advise a tire pressure for a specified load. Before removing the tire and rim assembly from the safety cage or restraining device, check to see that the tire beads are properly seated. If the distance between the guide rib or GG rib and the rim flange varies more than 2/32 of an inch, break down the assembly and inspect for damage. Chances are the bead did not seat properly on the rim. When using a tire mounting machine, obtain proper instructions and be sure to consult the manual for the tire mounting machine you will be using. On aluminum wheels, avoid using machines that clamp to the inside of the rim. Verify that the tire and wheel are properly matched using data from the Tire and Rim Association or tire manufacturer. Inspect the tire and rim for any damage. Apply a rust inhibitor to the tire side of the valve hole and also to the O-ring or grommet on the valve. Insert the valve stem. Tighten the valve to the recommended torque using a torque wrench. Put the wheel on the machine with the short side of the rim out. Lock the wheel to the machine. Lubricate the wheel and tire bead. Put the tire on the wheel, pushing the bead over the flange as far as possible. Insert the rotating arm in the central hole. Insert the disc of the mounting tool between the bead and the rim flange. Rotate the arm to mount the tire over the flange. If your machine does not mount both beads at once, start the second bead into the well. Insert the tool and rotate machine to mount the bead in the same way you mounted the first bead. Put the tire and rim assembly in the safety cage or other OSHA-approved restraining device. If the tire beads are not seated after mounting the tire to the rim, use a pressurized bead setting tool to help seat the tire beads. Use an extension hose with an air gauge and clip-on air chuck. Stand clear of the assembly. Both the tire and wheel manufacturer have inflation pressures. Only inflate to the lower pressure of the two manufacturers' specifications. Tire manufacturers may be able to advise a tire pressure for a specified load. Inflate to recommended inflation pressure. Before removing the tire and rim assembly from the safety cage or restraining device, check to see that the tire beads are properly seated on both sides. If the distance between the guide rib or GG rib and the rim flange varies more than 2/32 of an inch, break down the assembly and inspect for damage. Chances are the bead did not seat properly on the rim. Place the tire and wheel assembly over the studs while being careful not to damage the stud threads. Start the nuts on the studs by hand to ensure that they are not cross-threaded. Using approximately 50 foot-pounds of torque, snug the chamfered nuts in the chamfered bolt holes. Begin with the nut at the 12 o'clock position and snug using approximately 50 foot-pounds of torque. All nuts in a star pattern as shown. Do not tighten fully until all nuts have been seated. Tighten the nuts to 450 to 500 foot-pounds of torque, following the same star pattern with a calibrated torquing device, preferably a torque wrench. When installing the outer dewel, align the valve stems 180 degrees apart so that both valve stems are accessible through the handholds for inflation. Start the nuts on the studs by hand to ensure that they are not cross-threaded. Again, starting with the nut in the 12 o'clock position, snug all nuts in a star pattern as shown, using approximately 50 foot-pounds of torque. Once the nuts are seated, tighten the nuts to 450 to 500 foot-pounds of torque, following the same star pattern with a calibrated torquing device, preferably a torque wrench. Do not over-tighten the nuts on the studs. Do not lubricate the nuts and studs in the stud-piloted system, as this affects the clamping force. After the wheels have had time to seat on the hub, re-torque the wheels to 450 to 500 foot-pounds of torque using a calibrated device. Before re-torquing the inner cap nuts, loosen the outer cap nuts. Once the inner cap nuts are re-torqued, re-torque the outer cap nuts. This is typically done between 50 and 100 miles after installation. Maintain nut torque by re-torquing the wheels following initial installation at regular service intervals, or every 10,000 miles, whichever comes first. There are different piloting systems within the stud-piloted category that may use different studs or nuts. These systems may use different torquing values. Refer to the Accuride Safety and Service Manual for a comprehensive listing of these fasteners and their proper torquing values and procedures when servicing these wheels. Failure to follow instructions listed in the Safety and Service Manual may lead to wheel failure, which may cause an accident or injury. For hub-piloted wheels, lubricate the pilot pads or the center bore of the wheel with a drop of motor oil or rust inhibitor to prevent galling. This will also allow for easier removal at the next service interval. Position a pilot pad in the 12 o'clock position. Hub-mounted wheels use two-piece flange nuts to clamp the wheel against the hub and drum. Before reusing old nuts, make sure the nut and flange rotate freely and are not seized. If they are seized, replace the nut. Lubricate the joint between the hex and flange with 1 to 2 drops of motor oil. Inspect the studs for damage. Put 2 to 3 drops of motor oil on the end of each stud. Flange nuts generate higher clamping force. Always use grade 8 studs on hub-piloted mounting systems. Wheel guards were developed to prevent deterioration of the mating surfaces and extend the service life of wheels. Wheel guards may be placed between the drum and wheel, and between two dual wheels, but not between the hub and drum. Wheel guards help prevent rust and corrosion on mounting surfaces. Wheel guards are recommended with aluminum wheels to help maintain their finish, specifically when dissimilar metals would be in contact causing galvanic corrosion. Lift the wheel onto the hub pilot pads using a dolly or tire lifting bar. Be careful not to damage the threads or bend the studs. When installing the outer dewel, align the valve stems 180 degrees apart so that both valve stems are accessible through the handholds for inflation. The nut tightening sequence begins with the nut in the 12 o'clock position. Always start threading the nuts by hand before snugging the nuts up to prevent cross-threading. You may use a wheel protector to prevent damage to the aluminum finish. Snug the nuts up to the wheel in the star pattern. Do not fully tighten until all nuts have been seated. Tighten nuts to 450 to 500 foot-pounds of torque using a calibrated torquing device, preferably a torque wrench. Do not over-tighten nuts. After the wheels have had time to seat on the hub, retorque the wheels to 450 to 500 foot-pounds of torque using a calibrated device. This is typically done between 50 and 100 miles after installation. Maintain nut torque by retorquing the wheels following initial installation at regular service intervals, or every 10,000 miles, whichever comes first. Always use a hub-piloted wheel on a hub-piloted hub and a stud-piloted wheel on a stud-piloted hub. Never use a hub-piloted wheel with stud-piloted fasteners or a stud-piloted wheel with hub-piloted fasteners. Stud-piloted wheels are identified by chamfered nuts and chamfered bolt holes. Hub-piloted wheels generally have bolt holes that are not chamfered and use two-piece flange nuts. For all disc wheels, make sure there is a solid backup diameter from the hub or brake drum with a full 360-degree contact surface to support the wheel. Regular inspections can help you identify and deal with wheel issues before problems occur. For more information on servicing wheels and wheel components, Accuride will send at your request Accuride Safety and Service Manual, Accuride Service Videos, Wheel Out-of-Service Wall Charts, Hub-Piloted, Stud-Piloted Wheel Mounting System Identification Chart. For technical support, please call 1-800-869-2275. Accuride Wheel End Solutions devotes the same attention to the finishing of our wheels as to the engineering and manufacturing, and offer a variety of finishing options to ensure you get the performance you need from your wheel. For standard aluminum wheels, a wax coating can be applied to the appearance surface of new wheels. When cleaning aluminum wheels, use a sponge or a cotton cloth and mild non-alkaline detergent and warm water. After rinsing and wiping dry with a clean, lint-free cloth, apply car wax to protect the exposed aluminum surface and enhance its luster. Thereafter, clean the wheels with water from a high-pressure hose to maintain their like-new appearance. Aluminum buffing pads and polishes may be used on bare aluminum wheels to enhance their luster. Do not use buffing pads and aluminum polish on AccuShield or AccuArmor wheels, as it will dull the surface. To learn more about Accuride wheels, visit our website at www.accuridewheelendsolutions.com. Again, for technical support, please call 1-800-869-2275. You can also find additional reference information in the Accuride Rim Wheel Safety and Service Manual and in the ATA Technology and Maintenance Council's Radial Tire and Disc Wheel Service Manual. Accuride Wheels. Quality you can depend on. From Accuride Wheel End Solutions.